In this video, we're going to basically focus on alkane, to be specific, isomers of alkane. So normally isomers are a compound that has the same molecular formula but different chemical structure. So they have the same molecular formula but different structure. Let's look at one example and see. So suppose we have pentene. You're asked to draw the isomers of pentene. And pentene has the formula of C5H12. So you also draw the isomers of pentene, and pentene has the molecular formula C5H12. Pentene is an alkane. So what we're going to do, the first thing we're going to do is we first take our time to draw what are the different chemical structure can you find other than finding one from the other. So that's what we call isomers. But as per the compound, each of the compound have different kinds of isomers. So we on pentene. Pentene is our first example. Let's see what's going to happen. So I'm going to take my first example, which is pentene, and here I'm going to draw 5 carbon because I want to draw pentene isomers. So I have 4 carbon here, and then there's going to be 2 here, there's going to be 2 here, there's going to be 2 here, and 3 here. So this becomes N-pentene. So this is my first structure, and my first structure I drew is N-pentene. Second structure. So I've drawn N-pentene. What are the different kinds of structure can I draw? So I'm going to draw 4 carbon. Instead of me drawing 5, I'm going to draw 4. So I'm going to say 1, 2, 3, 4. But in doing this, I'm going to have 3 hydrogen here. Initially I have 5, so I drop 1. So I'm going to drop 1 as a branching to this compound. So I'm going to drop 1 carbon here, making this to be actually an sargine here. So I'm going to get hydrogen here, I'm going to get 2 here, I'm going to get 3 here. So this becomes second isomers. Look, 1, 2, 3, 4, 5. I have 1, 2, 3, 4, 5 carbon, and so my second isomer have already been joined. Next thing, I'm going to name my second isomers. Remember my last video? So what we're going to do is that we check the longest side. 1, 2, 3, 4. 4 is the longest side, and 4 is butene. So the next thing we're going to do is to identify the shortest side. So we have 1, 2, 1, 2, 3. So this is our rest side. Metal group here is on carbon number 2. So what we're going to do, naming this compound, going to be 2 meta butene. So 2 meta butene becomes our second isomers of pentene name. So remember, have isomers 1, isomers 2. Let's move to third isomers. So we have third isomers. Our third isomer, we're going to draw 3. Since we have 4 carbon, we're going to draw 3 carbon again. So I have 1, 2, 3. So in drawing 3, I initially have this chain here. So I'm going to drop this here. I'm also going to take this, bring this here. So I'm going to attach 3 hydrogen here. I'm going to attach 3 hydrogen here. Remember, I still have 5 carbon. 1, 2, 3, 4, 5. So next thing I'm going to do is to name this compound. So this becomes my compound 3. So in naming this compound, what can I do? It means that I'm going to check the longest side. 1, 2, 3, 1, 2, 3. Every side is equal. So what I'm going to do now is to take this side. 1, 2, 3. 3 is propane. Now on carbon 2, because if I check from so 1, 2, 1, 2, I obviously have the same council for this thing. So it means I can check for anywhere. So, but on carbon 2 here, I have 2 different metal group on up and down, both up and down. So what I'm going to do is that I remember I have 2. In my last video, I said 2 mean that. So I'm going to say repeat the number and read that to the number. But since we have 2 meta, I'm going to repeat the number. So I'm going to say 2 combine 2 the meta propane. So this becomes my third isomers of pentene. So in general, pentene actually have 3 isomers. So there's no different isomers we can find other than this again. Let's move to our next example. You see, let's move to hexene. So suppose you are asked to find the isomers of hexene. Hexene is C6H14. So hexene is C6H14. So you are asked to find the isomers of hexene. So the next thing you do, first thing we're going to do is to draw, we're going to draw 6 carbon. So we have 1, 2, 3, 4, 5, 6. So in drawing 6 carbon, we have 3 hydrogen, 2 here, 2 here, 2 here, and 3 here. So this becomes one isomers, and this becomes N-hexene. So this becomes N-hexene. We move to our second isomers. In our second isomers, we're going to drop this carbon. So this carbon going to be dropped. We're going to read this and drop this carbon as sergeant. So we're going to say 1, 2, 3, 4, 5. So we're going to drop this carbon here, and we're going to have 3 here, we're going to have 2 here, we're going to have 2 here, we're going to have 2 here, and we're going to also have 3 here. So this becomes our second isomers. So in naming this, we have 1, 2, 3, 4, 5. Initially, this is the parent name of this pentene, but we're going to check from 1, 2, 3, 4, 1, 2, 2 is the shortest. So our name here going to be 2 meta, 1, 2, 3, 4, 5, 2 meta pentene. Why we say pentene? Because the parent name is pentene. Why we say 2 meta? Because this meta group is on carbon 2. Let's move to second isomers. I'm gonna second isomers. We actually have this structure. I'm gonna take this meta group as sergeant, attaching it around here. So in this case, it means I'm gonna draw 4 carbon. I'm gonna draw 1, 2, 3, and 4. So in drawing 4 carbon, it means I can do something like this. I can take this. Initially, I have this meta group here. I can also read another meta group of it. It means I will have 2 here, I will have 3 here, and I will have 3 here. So in naming this compound, what we're gonna do? In naming this compound, it means that we're gonna get 1, 2, 3, 4. The parent name of this compound is already put in. 1, 2, 1, 2, 3. So on carbon 2, we have 2 different meta groups. So the name here is going to be 2 combine 2 the meta butene. So this becomes the name of the first compound up there. So we're going to move to the next. Our next compound. Next compound is carbon. So this becomes isomers 3. So isomers 4 is this. In isomers 4 we have isomers 4. We're going to look at this isomer 3. So we have 4 carbon. So I'm going to drop this branch on this side, making it to look different, but we'll have the same. So I'm going to write 1, 2, 3, and 4. But in this case, this meta group will come here, and I'm going to change direction of this meta group here. And here, I'm going to have hydrogen. I'm going to have 3 hydrogen here. So I have different group, different structure. So in naming this compound, different 4 names still remain the same protein, but the the position is changed. If I check one, so I have 1, 2, 3, 1, 2, 3, same kind of metal group. It means the name of this compound will change, and I'm going to write the name up here. So the name of this compound will be 2 combined metal butene. So this becomes the name of this compound. So maybe you're going to be thinking, can we get different structure other than this? I think no, because why? If you take this metal and bring here, you're going to get same thing. And if you take this metal and bring here, you're going to get same thing. So in so doing,